Welcome to another thrilling episode of Tell Me Why series, where we dive deep into the wildest and most mysterious weather phenomena our planet has to offer. From the icy plains of Antarctica to the scorching heart of the Sahara, our planet experiences a breathtaking range of weather phenomena. Some are beautiful, some are destructive, and some are downright bizarre. Stick around till the end, because you won't believe some of these. Tell me why blizzards are so dangerous. The Arctic wilderness, a realm of unforgiving beauty, is home to one of nature's most formidable spectacles, the blizzard. Imagine standing on a vast frozen plain, the wind howling around you like a banshee. Strong winds, often exceeding 35 miles per hour, whip up freshly fallen snow, creating a blinding whiteout. Temperatures plummet, the biting cold seeping through even the thickest layers of clothing. The lack of visibility makes navigation nearly impossible, increasing the risk of becoming disoriented and lost. And with each passing hour, the threat of hypothermia looms large, a silent killer that can claim even the most experienced adventurer. Tell me why the poles are getting warmer. Our planet, a delicate blue sphere, is a marvel of cosmic balance. Spinning through the vastness of space, it harbors life in a fragile equilibrium. However, this balance is being disrupted by a dramatic transformation. The Arctic and Antarctic, once considered frozen wastelands, are now warming at an alarming rate. These regions are heating up twice as fast as the rest of the planet, a phenomenon that is unprecedented in recorded history. This rapid warming is causing glaciers to melt at an accelerated pace, leading to significant changes in the landscape. Billions of tons of fresh water are being poured into our oceans, raising sea levels and altering marine environments. The influx of fresh water is changing ocean currents, which in turn disrupts marine ecosystems and the species that depend on them. These changes are not isolated. They are impacting weather patterns across the globe, leading to more unpredictable and severe weather. The Arctic, once a reliable refrigerator for the Northern Hemisphere, is losing its ability to regulate global temperatures. This loss of regulatory function is contributing to more extreme weather events, from heat waves and droughts that parch the land to intense storms and floods that devastate communities. The effects are far-reaching and profound. Tell me why heat waves happen. The sun, a life-giving star, can also be a source of intense heat, capable of transforming landscapes into scorching deserts. When high-pressure systems trap warm air over a region for an extended period, the result is a heat wave, a silent and invisible killer. Temperatures soar, breaking records day after day. Heat waves are particularly dangerous for vulnerable populations such as the elderly, infants, and those with pre-existing health conditions. The human body struggles to regulate its temperature in extreme heat, leading to heat exhaustion, heat stroke, and even death. These extreme heat events are a stark reminder of the power of nature and the urgent need to address climate change. Tell me why hurricanes have names. Hurricanes, those swirling behemoths of the sea, are among nature's most awe-inspiring and destructive forces. But did you know that these storms have names assigned to them like characters in a dramatic play? The practice of naming hurricanes began as a way to improve communication and tracking of these powerful storms. Before names were used, meteorologists relied on latitude and longitude coordinates, which proved cumbersome and confusing. Today, the World Meteorological Organization maintains a rotating list of names for Atlantic hurricanes, using both male and female names in alphabetical order. Names like Katrina, Harvey, and Sandy evoke memories of devastation and loss, underscoring the importance of preparedness and early warning systems. Tell me why jet streams affect the weather. High above the Earth's surface, invisible to the naked eye, flow rivers of air that shape our planet's weather patterns. These are the jet streams, fast-moving air currents that circle the globe, influencing everything from temperature to precipitation. The jet stream forms a boundary between cold polar air and warmer air from the tropics. This temperature difference creates a pressure gradient, which drives the jet stream's powerful winds. The jet stream's path is not constant. It meanders and shifts, influenced by factors such as the Earth's rotation, temperature differences, and the location of mountain ranges. These shifts can have a dramatic impact on weather patterns, bringing unexpected heat waves, cold snaps, or storms. Tell me why air feels heavy before a storm. Have you ever felt a strange heaviness in the air, a sense of oppressive stillness before a storm? It's not just your imagination. There's a scientific explanation for this phenomenon. Before a storm arrives, the air pressure drops, creating a low-pressure system. This drop in pressure causes the air to become less dense, meaning there's less oxygen available. At the same time, humidity levels rise before a storm. Warm, moist air is drawn into the low-pressure system, increasing the amount of water vapor in the air. Our bodies are surprisingly sensitive to these changes in air pressure and humidity. Tell me why oceans help regulate Earth's climate. Our planet is a complex and interconnected system, with each element playing a vital role in maintaining the delicate balance of life. From the smallest microorganisms to the largest mammals, every living being contributes to this intricate web. At the heart of this system lie the oceans, vast bodies of water that cover over 70% of the Earth's surface. These immense expanses of water are home to countless species and ecosystems. The oceans are not just a source of life, they are also the planet's thermostat, regulating global temperatures and influencing weather patterns. The interaction between the ocean and the atmosphere is crucial for weather formation. They act as a massive heat sink, absorbing and storing vast amounts of solar radiation. This process helps to moderate the Earth's climate. This absorbed heat is then distributed around the globe by ocean currents, moderating temperatures and influencing climate patterns. These currents act like conveyor belts, moving warm and cold water across the planet. This constant circulation of heat helps to maintain a relatively stable climate, preventing extreme temperature swings and creating the conditions necessary for life to thrive. Without this balance, our planet would be a much harsher place to live. Tell me why some rain is acidic. The rain, a life-giving force that nourishes our planet, can also be a harbinger of destruction when tainted by human activities. This natural phenomenon, which we often take for granted, can turn into a deadly weapon against the environment when mixed with pollutants. Acid rain, a consequence of industrial pollution, is a stark reminder of our impact on the environment. The pollutants released from factories and vehicles rise into the atmosphere, where they undergo complex chemical reactions. This is the reality of acid rain, a phenomenon that occurs when sulfur dioxide and nitrogen oxides, released from burning fossil fuels, react with water vapor in the atmosphere. These reactions are not just isolated events, they are part of a larger, more troubling pattern of environmental degradation. These chemical reactions form sulfuric and nitric acids, which dissolve in rainwater, making it more acidic than normal. This acidic rainwater then falls back to Earth, affecting everything it touches. When this acidic rain falls to the Earth, it can have devastating consequences for ecosystems, wildlife, and even human-made structures. Forests suffer as trees lose their leaves and nutrients, while historical monuments and buildings erode faster than ever. Lakes and rivers become too acidic to support aquatic life, killing fish and other organisms. The delicate balance of aquatic ecosystems is disrupted, leading to a cascade of negative effects that can last for generations. Tell me why cities are often warmer than rural areas. Cities, those bustling centers of human activity, are often several degrees warmer than their surrounding rural areas. This phenomenon, known as the urban heat island effect, is a consequence of urbanization and its impact on the environment. Imagine a city as a giant heat sink, absorbing and trapping solar radiation from buildings, roads, and other surfaces. These materials absorb heat during the day and release it slowly at night, creating a dome of warm air over the city. The lack of vegetation in urban areas exacerbates the problem. The urban heat island effect can have significant consequences for city dwellers, contributing to heat stress, respiratory problems, and increased energy consumption for cooling. Tell me why the sun feels hotter in summer. As our planet embarks on its annual journey around the sun, we experience the ebb and flow of seasons, each marked by distinct changes in temperature and daylight hours. During the summer, the hemisphere tilted towards the sun receives more direct sunlight, meaning the sun's rays hit the Earth at a steeper angle. This steeper angle concentrates the sun's energy over a smaller area, leading to higher temperatures. Think of it like using a magnifying glass to focus sunlight. The more concentrated the rays, the more intense the heat. Thanks for watching. We've journeyed from the icy poles to the scorching equator, uncovering some of the most shocking and intriguing weather facts our planet has to offer. From the fury of blizzards to the silent threat of heat waves, from the powerful jet streams that circle the globe to the delicate balance of our oceans, we've gained a new appreciation for the forces that shape our climate and weather patterns. If you found these weather facts as shocking as we did, make sure to like, subscribe, and hit the bell icon for more intriguing content. See you next time.